Hi guys, it's Dr. Bay and here's Bugsy, and today we're going to go over Introduction to Carboxylic Acids, so stay tuned.
Organic chemistry,
taught by Dr. Bay.
reaction mechanisms,
Reactants to products.
retrosynthesis,
Target deconstructing.
molecules, spectroscopy. Soaring through the sky, triumphantly we fly, give rise to the complexity of life. Living on a dream across the seven seas, learning about spectroscopy. Organic chemistry.
Carboxylic acids are compounds that contain a COOH group, as shown here in blue. Carboxylic acids can be found in many molecules in nature, as well as many drug molecules. Some examples are acetyl salicylic acid, also known as aspirin, which is a widely used analgesic. Isotretinoin is used in the treatment of acne, and 4-aminosalicylic acid is used in the treatment of tuberculosis. Just as a review, carbonyl compounds consist of several different functional groups like ketones, aldehydes, carboxylic acids, esters, and amides. For this next set of reactions, we will be focusing on reactions with specifically carboxylic acids. So, how can we make them? Well, we can undergo an oxidation of primary alcohols using Jones reagent, or we could undergo ozonolysis to cleave an alkyne into two carboxylic acids. A few other ways to form carboxylic acids are hydrolysis of nitriles. If you start with an alkyl bromide, undergo an SN2 reaction with NaCN, you'll get the following intermediate. Then treat the nitrile group with an acid like H3O+ under heat to form a carboxylic acid. Another way to form carboxylic acids is by using a Grignard reagent with CO2 in the first step, followed by H3O+ in the second step. Let's take a look at the mechanism. If we rewrite the Grignard reagent to show the lone pair and negative charge on the R group, the lone pair can act as a nucleophile to attack the carbon of CO2 while one of the carbonyl pi bonds breaks to form a new lone pair on oxygen. This forms a carboxylate ion intermediate where one of the lone pairs on O- gets protonated by H3O+ to form the carboxylic acid final product. We can also reduce carboxylic acids to primary alcohols. One way is to use lithium aluminum hydride, or LiAlH4, but note that this reagent will reduce all carbonyls to alcohols. In this example, notice that there is both a ketone and a carboxylic acid. When the starting molecule reacts with lithium aluminum hydride, both the ketone will reduce to a secondary alcohol, as well as the carboxylic acid will reduce to a primary alcohol. Now, if you want to be more selective, you could use borane or BH3 in THF, which will only reduce carboxylic acids to primary alcohols. So if we look at the same example, but now using borane in THF, only the carboxylic acid will reduce to a primary alcohol and the ketone will remain untouched. So in summary, the different ways to form a carboxylic acid include oxidation of a primary alcohol using Jones reagent, ozonolysis of an alkyne to form two carboxylic acids, hydrolysis of nitriles, and carboxylation of Grignard reagents using CO2 and H3O+ to form a carboxylic acid. And ways to reduce carboxylic acids are either using LiAlH4 or BH3 in THF.
Organic